So we are going to start a new topic in physics named kinematics. We study in kinematics about motion without going into detail cause of motion. It means that we don't want to know how motion comes in that particle, but only we study about motion. We only study about motion of particle. We only study about motion of particle in this topic or this chapter. So in kinematics there is three topics. First is rectilinear motion. First one is rectilinear motion, second is projectile, and third is relative motion. So we are going to study about what is motion and what is rest. What is motion and rest? It is basically properties of observer and object. For example, if we are moving in a train, this is train and two person is sitting in that train and third person is sitting outside of the train. So position means position of B with respect to A is stationary. Matlab B is not moving with respect to A. But if we see according to person C, then A and B both are moving. What is meaning that? It means that A and B are in motion with respect to C, but A and B are with respect to each other at rest. So what does it mean that? What does it mean that rest is if particle is stationary with respect to observer. If particle is stationary with respect to observer, then we say that particle is at rest. But if particle is moving with respect to observer, then we say that particle will be in motion. So we have studied about rest and motion. What is meaning of rest? Rest is position with respect to observer. That if particle is not moving with respect to observer, then we say that particle is at rest. But if particle is moving with respect to observer, then we say that particle is in motion. So after that we going to start. Suppose that this is y-axis, this is x-axis. What is this is x-axis, this is y-axis. Suppose this is initial position of particle, this is final position of particle. What does mean that? Particle is initially at that position and after some time particle is at that position. So if we want to know how much distance particle travel, so we can say that particle travel R final minus R initial. How much distance particle travel? R final minus R initial. It will come out like this vector. Because if I say R final equal to R initial plus S, so this vector and this vector resulted come out will be this vector. What is S? S is defined as displacement. S is defined as displacement. What will be it be? R final minus R initial. So what is displacement? R final minus R initial. What is it? What does it mean? That final position of particle minus initial position of particle. It will be displacement if I write in form of vector. So what is displacement and distance? What is displacement and distance is, we start displacement and distance. We cannot compare displacement and distance because displacement is a vector quantity and distance is a scalar quantity. We cannot compare a scalar with vector. So displacement is position of particle. final position of particle minus initial position of particle. But distance is magnitude of position, magnitude of displacement. Magnitude of displacement is distance. So all of you are getting me? Displacement is final position minus initial position, but distance is magnitude of displacement. So we cannot compare displacement and distance because displacement is a vector quantity, but distance is a scalar quantity. You cannot compare a scalar with vector. Let's see some example. If I say that my position is at A, after some time I am moving in a straight line, my position is at B. Suppose that this distance is D. So here my displacement and distance will be same. I am telling about magnitude of displacement. It means that magnitude of displacement and distance is same. What does it mean? That if magnitude of displacement and distance is same, then we say that particle is moving in a straight line. So if question is saying that if particle is having magnitude of displacement and distance is same, then we say that particle is moving in a straight line, because without a straight line it will not possible to have same distance and displacement. Suppose that particle is moving along circle. I have to particle start from here, after some time particle come out this position. I name this position O. So we can say that displacement is R. Displacement is R final minus R initial. R final and R initial is same. It will be come out to be 0. But we cannot represent vector equal to 0. We have to put null vector. We use null vector. We cannot put vector equal to 0. So we have to use null vector. What is distance? Distance, suppose if circle is having radius r, so distance will be 2 pi r. But displacement is 0. Here displacement is 0, but distance come out to be 2 pi r. So we say that particle is not moving in a straight line, because distance is not equal to displacement. If distance is equal to displacement, then we say that particle is moving in a straight line. So I have to erase it. I'm going to give a question. Suppose a circle having radius r moving, suppose I am saying this point. After some time, this position of A come out to be like this. So what is distance of this? This distance will come out to be pi r. Why? Because particle is moving pi r. So this distance will be come out to be pi r. This distance is r and this distance is r. So displacement of particle will be come out to be 2 r square plus pi r square. Why it is? Because it will be right angle triangle, and this displacement will be hypotenuse of the right angle triangle. This perpendicular will be 2r and this will be pi r. So we will calculate displacement. It will be come out r square root of 2 plus, not 2, 4 plus pi square. I am writing here magnitude of displacement. I have to. So it is clear. Now I erase it. So now we are going to define velocity. What is velocity? Rate of change of displacement. Rate of change of displacement is velocity. What does it mean? If S vector is R final minus R initial, it can be write delta R. What is meaning that delta R? Delta is a difference between final minus initial. So velocity will be defined. Suppose particle is at A. After some time, particle is at B. After suppose delta time. So what will be velocity of particle? Velocity of particle will be come out to be V equal to delta R by delta T. What does it mean? Means R particle is at initially at Ri, and after some time, after delta time, particle is at Rf. So we have to divide displacement by delta time. It means that velocity is a rate of change of position. This is a average velocity. What is meaning of average velocity? If difference of delta R is approximate more than, then we have to use delta. Suppose this is a average velocity. Average velocity is delta R divided by delta T. So what is average velocity? Average velocity is delta R by delta T. It will write like average velocity will be R final minus R initial divided by delta T. So what is average velocity? Average velocity will be come out R final minus R initial. It means that final position of the particle minus initial position of the particle. So if I talk about direction of average velocity, what will be direction of average velocity? It will be direction of R final minus R initial. Not depend on R final or either on R initial. It will depend on R final minus R initial. So if direction of average velocity will be direction of R final minus R initial. So direction of average velocity R final minus R initial. So suppose if I write like, suppose V equal to delta R divided by delta T. If suppose if delta T tending to 0, what does it mean? That suppose particle is at A and after infinitely small, it is a small time after particle is at B, in very small time, delta T tending to 0, what does mean? Dt means dt time. After dt time, particle is at B. So displacement will be come out small dr. What is meant? R initial, this is R final. This is distance. This displacement is very small, so we can write R final minus R initial is dr. If displacement is very small, so if displacement is very small, so we can write velocity is delta R divided by delta T. Limit delta T tending to 0 means for very small time. So displacement is very small time, dr, or this is dt. So this velocity will be instantaneous velocity, not average velocity. So instantaneous velocity will be dr by dt. If displacement is very small in dt time, then we write velocity dr by dt. This velocity is instantaneous velocity. What will be direction of instantaneous velocity? If suppose particle is moving in x direction, so this instantaneous velocity will be dxi divided by dt. Slope of tangent of position time graph, direction of instantaneous velocity, and direction of average velocity will be r final minus r initial. So if I write here, if particle is moving in x, suppose this is y, this is x, this is not, this is y, and this is x. If particle is moving like this, so what we write, instantaneous velocity will be dxi cap divided by dt. This is unit vector along x-axis. If particle, so this velocity will be right vx. So instantaneous velocity along x-axis is dx by dt. If I talk about speed, so magnitude of velocity will be speed. If I take magnitude, if I say instantaneous velocity along x-axis, instantaneous velocity along x-axis, that will be vx equal to dxi divided by dt. What will be direction of instantaneous velocity? It is a slope of tangent of position time graph. So what is slope of tangent of position time graph? What will be speed? Speed is magnitude. If I take magnitude, then it is speed. So speed is dvx by dt. Speed in x is dx by dt. We cannot talk about direction of speed because speed is a scalar quantity. So we cannot compare speed with velocity. We only compare magnitude of velocity and speed. So if I write here, what is speed? Or if I say instantaneous speed, instantaneous speed is dr divided by dt. R is a position vector. What is meaning of instantaneous speed and velocity? Suppose particle is moving in a straight line from A to B. Suppose at 10 p.m. particle is at A. If I say what is velocity after very small time, suppose 3.00001 second. So velocity will be changed very small. So velocity will be also here is v. So what is this? Is instantaneous velocity. I am talking about at that instant. Means if I talk about at what is velocity at A, means at 10 p.m. If I talk velocity at, suppose this point is Q. So what is velocity at this time? Suppose this time is 10 is to 2 second. So 10 is to 2 minutes. So if I talk velocity at this point, then it will be instantaneous velocity. But if I talk what is velocity along A to B, so it will be average velocity because I am taking time interval large. This is large time interval. This is a small time interval. That's why this velocity is instantaneous velocity and this velocity is average velocity. So suppose particle is moving along this curve. This is y-axis, this is x-axis. Initial velocity of particle, suppose initial velocity is 0. Not initial velocity, I am talking initial position. Particle is at origin, particle is starting from this. So if particle is moving along this curve, so if I want to check what is average velocity at A and instantaneous velocity at A, talk about average velocity at B and instantaneous velocity at B. So for instantaneous velocity, we have to draw a tangent. We have to draw what? Tangent. So tangent will be give direction of instantaneous velocity. If I talk about what is direction of instantaneous velocity at this point, so we have to draw tangent and this tangent will give direction of instantaneous velocity. But if I talk about average velocity, so what will be direction of average velocity? We have to join initial point to final point. So this direction is direction of average velocity and this direction is direction of instantaneous velocity. So what is direction of instantaneous velocity? It will be slope of tangent. But if we talk about average velocity, so we have to define what is r final minus r initial. Not only r final, here r initial is 0, so that's why r we have to write that for direction of average velocity is r final minus r initial divided by delta t. Here we have to put vector. Here position is r initial is 0, so direction depends on r final divided by delta g. Direction will be r final vector along this. So average velocity along this axis, this direction, and instantaneous velocity we have to draw tangent. So slope of tangent will give direction of instantaneous velocity. So we have write average velocity is, so we are going to have question on average velocity. If suppose average velocity will be this and so suppose position of particle at A is 3, 4, 5. After time 5 seconds. Position at B. What is? Suppose 4, 5, 6. So we have to calculate average velocity. So first we have to write this position in form of vector. So R initial, it means R at A. What will be right? Like 3I. Because this is a displacement in I direction, means x axis. So we have to put unit vector I. This will be 4j and this will be 5k. Suppose RB we have to write what? 4I plus 5j plus 6k. So what is delta r? Delta r means rb minus ra. What is this? Is a final position, this is initial position. So we have to subtract from r final minus r initial. It will be come out to be I cap plus j cap plus k cap. This is delta r. What is time taken by the particle? Time taken by the particle is 5 seconds. So we write V average is I cap plus j cap plus k cap divided by 5. This is average velocity. If anyone talk about what is speed, so we have to take magnitude of this. What will be magnitude of average velocity? What is magnitude of this? This magnitude of 1 square plus 2 is 1 square plus 1 square. And what is magnitude of 5? Magnitude of 5 is only 5. So it will become out root 3 by 5 meter per second. What is average velocity? Root 3 by 5 meter per second. And what is average speed? I am talking about what is average speed. Average speed is root 3 by 5 meter per second. What is average velocity? Average velocity is what? I cap plus j cap plus k cap divided by 5 meter per second. So now we are going to revise what we have studied. We are studying about kinematics. In kinematics, we study only about motion without going into detail of cause of motion. So what we have studied? What we study about displacement. First, then distance, then speed and velocity. What is displacement? Displacement is if suppose I am moving. What we talk about displacement? We talk about displacement. Suppose a particle is at A. This coordinate is 3, 4, 5. And after some time this particle is at B. What is this coordinate? This coordinate 4, 7, 8. What is 4, 7, 8? So what is displacement of the particle? To know displacement of the particle, we have to write this is in form of vector. We have to write this is in form of vector. So what will be position of A? RA is 3I, 4J and 5K. What is position? Yeah, I have write 4, 7, 8. B. So RB is 4I plus 7J plus 8K. So what is displacement? Displacement is RB. Why RB? Because particle is at finally B minus RA. So displacement will be 4 minus 3 यानी कि I plus 3J plus 3K. What will be magnitude? magnitude of displacement is distance. So magnitude of displacement is what? A square root of 1 square plus 3 square plus 3 square. This is 9 and 9, 18, 1, 19. Root 19. So we talk about some general term, some general question, and a particle is moving in a circle. So if suppose particle start from here, after some time particle is here. So what is displacement? Displacement is 0 and distance is 2 pi r. Suppose if circle is having radius r. So what is distance? Distance is 2 pi r and displacement is 0. Suppose a person start to go to a school from point A and come out from school at point A. So what is displacement? Suppose this is 5 meter. So what will be displacement? A particle start from here and come out here. So what is displacement? Displacement will be 0, but distance will be, what is distance? If we talk distance, so distance is 10 meter. Suppose any particle moving along this curve. This is a semicircle having radius, suppose 3 meter. This is 5 meter. Suppose this distance is 2 meter, this distance is 5 meter, and this distance is 6 meter. So we have to calculate distance and displacement. A particle starts from A and go at C. So what is distance? Distance will be 2 this plus pi into r, yani ki 3 pi. It means 3 pi plus 5 pi plus 6. So what will be come out? 3, 2 and 5, 7 and 6, 13 plus 8 pi. It is distance. But if we talk about this distance is pi r because it is a circumference of semicircle. Or this distance will also be pi r. Here radius is 5, here radius is 3. So if we talk about displacement, so what will be displacement? We have to talk about displacement. So we draw, if we are talking about displacement, so we draw a straight line from initial position to final position. So we have to go like this. So what will be displacement? This displacement is, magnitude of displacement is here 2 meter plus here 6 meter, here 5 meter plus here 10 meter. Why 10 meter? Because this is the diameter. Diameter will be 2 times of radius. Yani ki it means that 2 into 5. And this is 6. So what will be 2 and 6? I'm right here meter. I'm in meter. So what is 6 and 2, 8, 5, 13 and 6, 19 and 10, 29. It is distance and displacement. This is a magnitude of displacement. So from here we will study in next class. Thank you.